Hey guys, what's up everyone? Welcome back again to another video tutorial from the AP3X Institute of Mathematics. My name is Akeen and this is another tutorial upload, part 2 that is, of our coordinate geometry complete tutorial video. Alright, now in part 1, a link will be in the description box below and it will be pinned in the comments. We had looked extensively at finding the gradient of a line in two different forms, both graphically and non-graphically, and we also have a bunch of questions that I had looked at where we were finding the x and y ordinate values, and of course using the gradient formula to do some transpositions. You definitely want to check that out if you haven't watched that video as yet. And of course, if this is the first time here that you are joining the channel as a student, the aim of this channel here is to guide each and every student along the curriculum of the CCSLC, SEA, CSEC, and other math related courses. All right, so if this is your first time here, consider smashing the subscribe button below, leaving a like if you're getting any sort of value from the content. Of course, please share this out to your math groups, study groups, so that others can be helped. And of course, leave me a comment with your suggestions, requests, and more down below. So we're going to pick up on where we left off, and so as promised, we were going to move on to finding the length of a line. That's what we're going to be looking at. All right, and so as you can see here on screen, that the distance / the length of a line formula was derived from the application of the Pythagorean theorem. Of course, that also is a video that I've done on my channel. Check the link in the description box below for that, where the square of the distance of the rise and the fall, that is the leg 1, plus the square of the distance on the run, which is leg 2, is equal to the square of the distance on the slope, which is represented by the hypotenuse. Now, by finding the square root of both sides of the equation, the length formula was derived. And here you can see here that the length formula is equivalent, or is equal, or implies that the distance is equal to the root of x2 minus x1 plus y2 minus y1, right? So this would be the run distance, or the difference between the run distance here and the rise and fall distance here. All right, now just as an intuitive understanding of the concept, what we say about the hypotenuse, if you are familiar with what we refer to as being the right angle triangle, then you would realize here that if I were to perhaps select a point, let's select, say, this point here, and let's select this point here. Okay, these are my 2 points that I'm looking at, and I need to find the distance of the line. Okay, so this here, I would create a right angle triangle. So here, and I would also connect, I think I went a bit too far. All right, here we go. And then I would come like here. So I would create a right angle triangle. And if we are familiar with one of my previous tutorial videos, we will know that this is actually the hypotenuse. All right, the long side, the HYPTENUSE. All right, so in this case here, the hypotenuse of the right angle triangle is actually representing the slope of the line. All right, the slope of the line. All right, and then we're seeing here that either this or this can be the legs. That can either be the legs here. So we can look at the fact that here we would have, say, the rise and fall distance, and we can say that this is the rise and fall. Okay, this would be the leg 1 or leg 2, doesn't matter. And down here would be the run distance, which naturally would be leg 2. Okay, so that's what I was trying to explain in the description up top, that according to the Pythagorean theorem, if we wanted to find this side here, then this side squared is going to be exactly equivalent, it's going to be exactly equal to this side squared plus this side squared. So we know that this is the rise distance, and from previous tutorial we know that the rise is the difference between the y values. Okay, so the distance between here and here is the difference between this y ordinate and this y ordinate. So that's y2 minus y1 plus x2 minus x1. Right, now you can interchange what you put first, but traditionally, because we plot a point using the format x followed by y, then I can stick with that by saying this just x2 minus x1 plus y2 minus y1. Now in the event that you choose to put the y calculation on this side and the x calculation on that side, you won't change your answer. What you can't do though is that you can't switch up here the x ordinate values. All right, okay, good. So that's what we're saying here. So that's what we need to remember. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Let's have a look at some examples here. All right, so some of the examples that we're looking at here is number 1. Given that a straight line has coordinate values of 5, 1 and 1, 6, you are to determine the length of the line. Right, and so this just requires a very basic application of the formula. So that's d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's then equal to the square root, and then we're going to begin to name our coordinate values. So we could say that this is x1, this is y1, this is x2, this is y2. Okay, so labeling our points, that is 6, pardon me, x2 is going to be 1 minus x1, which is 5, squared plus y2, which is 6, take away y1, which is 1, squared. Okay, that simply now equals to the square root of 1 take away 5 is negative 4 squared plus 6 take away 1 is 5 squared. So this naturally works out to be, when you square negative 4 all squared is 16, and 5 squared is 25. If we are to proceed, we'll find that d is equal to the root of 41. So we jump onto our calculators and we're going to find the square root of 41, and we'll find that the distance of this particular line here is 6.40, rounded up to 2 decimal places, units. Okay, and that is the length of our line. All right, not too bad, not too bad. Let's go down to example number 2. Hope you guys got that. Given that the line PQ has coordinate values 1, -5 and 3, pardon me, -3, 7, we have to determine the distance of the line. So sometimes we'll refer to it as being the distance of the line, sometimes we'll refer to it as being the length of the line. Okay, so once again, an application of the formula, d is equal to the square root of x2 minus x1, and that's going to be, say here, y2 minus y1. Okay, now I believe I did say earlier in a previous explanation that you're not allowed to switch up the x1 and x2 values. I think that you are able to do that, because you're still going to get the same answer considering that you're going to be squaring the value. But Traditionally, we just stick with a routine, and it's just always the x2 minus the x1 plus the y2 minus the y1. All right, so in terms of the ordinate values, then yes, you can switch up. You'll still get the same answer. All right, but we're going to keep it standardized. So once again, d is equal to, and before we start substituting, let us name our points. All right, so that's going to be x1, y1, that's x2, and that's y2. So once again, x2 is minus 3. Okay, and we're going to say here, so that's minus 3 squared. Sorry, pardon me. So that's minus 3. So that's x2, take away x1, so that's minus 3 minus 1 squared. Plus y2 is 7. Take away y1, so that's 7, take away negative 5. I'm going to square that. Okay, notice I put a double bracket here to separate my negative sign from my negative 5. So that's good. So that's going to be the square root then of negative 4 squared plus 7 take away negative 5. The two negatives clash, gives a plus. 7 plus 5 is 12 squared. So we're looking at here is that d is equal to the square root of 16 plus 144. Right, if we add both of those, we're going to find that our answer here is that d is equal to the square root of 160. So by finding the square root of 160, we'll find that our answer for this particular line here is 12.65 rounded to 2 decimal places units. All right, that would be the distance of this particular line here. All right, so that is an application of our formula for the distance of a line. All right, if you guys are good on that, then of course you can definitely get some questions. I'll leave a link to a site that will bring you directly to the distance of the formula practice paper. All right, so hopefully you guys are good on that. Let's move on to the next important application of coordinate geometry. Now what we're going to be looking at next is the midpoint of a line. All right, and this is how we find the central location, the exact center of a line that is drawn on a grid. Now it's kind of self-explanatory in terms of when we say midpoint, because it's the middle of a point, finding the central location, right, of a line. And so here it says that the term midpoint simply means the location point of the middle of a line that is drawn on open space or a grid. Simple as that. All right, the midpoint of a line can be determined by a formula as you are seeing here on screen. All right, so here we're looking at the fact that given that a point has coordinate values xm, ym, we know that typically this is how we name our point. X value, x coordinate first, y ordinate second. Xm is like me saying x1, and ym is like me saying y1. So given that we have a point that is labeled x1, y1, or x sub m, y sub m, then the midpoint formula is derived by the division of the x ordinate values by 2, comma y ordinate values by 2. So that's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. All right, so we've got to find some way, guys, to get that formula in our mental. Okay, now usually we denote the midpoint of a line by the use of the capital M, because in our previous tutorial we had looked at the fact that common M is the gradient. So we've got to remember that the common M is the gradient. So do not get the M's mixed up, guys. Okay, this M here is the gradient, and the capital M here is the midpoint. So just be careful of that a bit later in part 3. We're going to look at some advanced questions, so definitely want to stay tuned for that. All right, so we denote it by the capital letter M. The midpoint formula is pinpoint precise when it comes to the Cartesian plane, right? Because once you have calculated the coordinates of the midpoint, if you try to locate that position on the grid, you're going to find exactly that you will land in the middle of the line. I'm going to demonstrate that in a moment. Let's look at some examples of the midpoint formula. So before we go into the examples, let's have a look at a picture. So here we have a line, and here is the starting point of the line x1, y1 here, and here is the ending point of the line x2, y2. So there you can see that when we find when we find the sum of the x ordinate values, that is x1 plus x2 divided by 2, and when we find y1 plus y2 divided by 2, we end up with the midpoint value here of xy. All right, that is on the grid. And so the midpoint formula was derived like this here. We just take the x1 value here and we add it to the x2 value here and divide it by 2, and we take the y1 value here and add it to the y2 value here and we divide by 2. So you can follow this formation and the arrows to know what ordinate values you should add to get your formula all set up. Okay, so here are some examples, and we're going to demonstrate not only by calculation, but we're going to demonstrate on graph. So example number 1 here is a straight line passes through the points 1, -5 and 4, 8. We are to determine the location of the midpoint. So in order for us to determine the location of the midpoint, we are going to need to plot the points on the graph, and then we're going to calculate where its location is and then locate it on graph. So 1, -5, we already know how to plot points from previous tutorial, part 1. So 1, -5, so that is 1 to our what? Right, and 5 down, that's 1, 2, 3, 4, 5. So I would be at this location here, and then we're going to look at plotting the point here. We're going to look at plotting the point 4, 8. All right, so that's 1, -5, that's right here, and then we're looking at 4, 8. Okay, that's 4, 8. So 4, that's 1, 2, 3, 4, and all the way up 8, that's 1, 2, 3, 4, 5, 6, 7, 8. So I'm approximately here. Okay, those are my 2 points. Then I would then therefore grab my ruler and I would then make a connect those 2 points here. Pardon me, a little bit lean there, guys. Okay, drawn a little bit too far though. Let's just try that again. I'm gonna try to get it as perfect as possible. So still a little bit off, guys. Try to get it as perfect as possible. I think I got it now. That's a little better, right? As best as I can get it from this type of screen. All right, so that's my line here. Let's go ahead and calculate now the midpoint of this line. So therefore we're going to look at M being equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, as usual, we name our points. So we're going to say here that this is x1, y1, x2, y2. Plug our numbers in. So x1 is going to be 1 plus x2 is going to be 4. That will be divided by 2. And y1 is going to be -5 plus y2 is going to be 8 divided by 2. Alright, mathematically this becomes 5 over 2 comma negative 5 plus 8, that's 3 over 2. Now in order for us to locate this on the Cartesian plane, we're going to have to convert it to a decimal. So 5 divided by 2 is approximately 2.5, and 3 divided by 2 is approximately 1.5. So what this is saying is that the gradient, the midpoint location is located at taking 2.5 steps to my right and 1.5 steps up. So that's 2.5 steps to my right, so that's 1, 2, that would be 3, so this is halfway, 2.5 steps and 1.5 steps up, 1.5 step up, so this would be right here. Obviously my graph is not drawn pinpoint precise, so it's a little off, but it's approximately here. All right, so it would be approximately here. Okay, that would be approximately my midpoint. Right, perfect. Okay, so that is how we locate our position. So this is 2.5 comma 1.5. This is the coordinate value 1, negative 5, and this is the coordinate value 4, 8. Okay, perfect. And that is how we calculate our midpoint. Let's look at maybe another couple of examples. All right, so we're gonna be using the midpoint formula now to calculate ordinate values, because of course you're not necessarily going to always be asked to find the midpoint at an advanced level. For the CSEC level, I've never really seen a question that has actually been structured this way, but I know that it exists. So just in the event that you happen to be doing a math and you're searching for how you can use the midpoint formula to rearrange, then we can do it this way. All right, now I want you guys to pay very close attention to how I go ahead and approach this question. All right, so a straight line has a midpoint location of -3, 1. All right, we are to determine the x-ordinate value if the line passes through 1, negative 5 and x4. Now in part 1 we had done examples like these where naturally you are not, or traditionally you're just simply asked to find the midpoint or the length of the line, or you're asked to find perhaps say the x-ordinate or y-ordinate value given the midpoint. So we're going to be doing the same thing here, given the gradient. So we're going to be doing the same thing here. We're given the midpoint location and we have to rearrange the formula to find an ordinate value. So here we go, let's write down our formula. Traditionally, I've always said to you guys that once you're getting a question, practice to write down your formula. Practice to write down your formula, guys. So midpoint here is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, we're gonna have to make some comparisons here based on where our unknown ordinate value lands. All right, so here x1, y1, x2, y2. All right, so here we go. We're looking at the fact that the midpoint, which we are told is -3, 1, so that's -3, comma 1. All right, we're told is equal to x1, which we see here is 1, plus x2, here is x, divided by 2, comma, y1, which is -5, plus 4, divided by 2. All right, and I believe that, guys, this is supposed to be actually a half. Pardon me, this is supposed to be equal to a half. So I think I'm gonna have to change something here, guys. I think I may have made a typing error here. So this is actually supposed to be a half, or negative a half, pardon me. So this is supposed to be minus a half. All right, here we go. Okay, So here you can see that we have set up our equation here. So the midpoint is at the location 3 minus a half. And if you work this out, you'll find out that 1 plus x divided by 2 is going to be equal to the x ordinate value of the midpoint. So this first part here is going to be equivalent to minus 3. And if you work this out correctly, you'll realize that minus 5 plus 4 is actually equal to minus 1 over 2. So you can clearly see that minus a half is equal to minus a half. So on the right side here, which is the y ordinate value of the midpoint in its calculation, is equal to the y ordinate value that we have instructed over here. So therefore we can set up an equation and we can say minus 3 is equal to 1 plus x over 2. And we can solve that equation to find the x ordinate value. So by cross multiplying here, we'll find that, hey, minus 3 times 2 is minus 6. And that's going to be equal to 1 plus x. So if we work this out here, you'll find here that minus 6 take away 1 is equal to x. So the x ordinate value here, which is going to be x2, is going to be equal to minus 7. So the value that would have to go here would have to be minus 7 for the midpoint or coordinate to be minus 3 minus a half. All right. So a tricky little question where you can actually use your algebraic skills to navigate your way through the problem. Hopefully you catch a little understanding on that. All right. So what we did here is that we actually used the midpoint formula and we made a comparison between the ordinate values. All right. Let's do another example here. So the question is structured a bit different now, and it's saying here that we should determine the coordinates of the point of the intersection of the perpendicular bisector line for t, which is minus 1, 4, and q, 3, negative 2. Now, there is no indication or any word that or any direct word that would suggest that we need to find the midpoint, but this word here, bisector, is a key word in understanding that a perpendicular bisector passes through the midpoint of a line. And I've structured this question this way simply because there's going to be a concept in part 3 where we're going to be discussing the perpendicular bisector. So I'm kind of introducing this to you from now. So we have to determine the coordinate of the point of the intersection of the perpendicular bisector. The perpendicular bisector passes through the midpoint of the line. So we want to find out the location value of where the perpendicular bisector passes through. So this is just another way of saying, hey, find the midpoint. So the midpoint value or the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, practice to write down your formula, guys, because in this exam up here, which is a very strange example, right? I've never really seen one structured like this on CSEC. But here, practice to write down your formula. Two things can happen. You don't know the structure of the question. You could be in a reverse form, as well as it gives you time to reiterate the formula and remember it at all times. Okay, so m is equal to, and let's name our points, x1, y1, x2, y2. So x1 is negative 1 plus x2 is 3 divided by 2, comma, y1 is 4 plus y2 is negative 2 divided by 2. Right, so negative 1 plus 3, that's 2 divided by 2, comma, 4 plus minus 2 is 2, okay, divided by 2. So this nicely works out to be equal to 1, 1. So the location of this midpoint here of this particular line here is located at 1 1. All right, now I think I need to do a particular tutorial that applies to this question here. All right, as I said, it's not very common, but it does exist. Let's not rule anything out, right? Application, math requires application skills, so you've got to be prepared in the event that they do not ask you to find the midpoint, but they have given you the midpoint and ask you to find an x-ordinate value. So I'm going to try to create a video on this type of question, right? So let's just move right along to another important aspect. So hopefully guys, if you are clear on how to find and apply the midpoint formula, leave me a like down below. All right, so we are 30 minutes into our tutorial. It's time for you to just take a quick break, and you can return now, where we're going to be doing something more interesting. And of course, we're definitely going to be getting into the meat of the matter when it comes to the important aspect of coordinate geometry. All right, so we'll be back. All right guys, so we are back and we are ready and rearing to go. We're going to be looking at the equation of a line. All right, very important aspect of coordinate geometry. All right, so let's get into it. As you can see here on screen, that the equation of a line, the general equation, has the form y equal mx plus c. A lot of you guys are indeed familiar with this particular formula, y equal mx plus c. Now, there is also a standard form, right, of the equation, which is written as ax plus by plus c equals 0. So occasionally, depending on the structure, depending on the objective of the question, they may say write the equation of the line in the form y equal mx plus c, or write the equation of the line in the form ax plus by plus c equal 0. I have questions in this tutorial that shows you how to do both, so stay tuned for that. All right, let's move right down to some more information here. To determine the equation of the line, we would need to obtain the values of the slope, and we're going to have to determine the value of the intercept on the y-axis. So the value of the line slope, which is m, we already know how to calculate m. I've placed a formula down here to remind you. And of course, the intercept on the y-axis, which is the c part of the equation, which is here. Okay, this here is our intercept. We need to calculate m, and we need to calculate c here. All right, now as a reminder, we would have already covered how to find the gradient of a line by using the formula. That would be a video that I had made in part 1, so definitely check that out if you're not familiar with how to find the gradient. A link will be in the description box below. Of course, the gradient formula here is m is equal to y2 minus y1 divided by x2 minus x1. All right, and that's called a slope formula. So therefore, by substituting any pairs of points, or any pair of points in the equation along with the gradient, we can calculate the y-intercept, hence rewriting the values obtained in the equation in the form y equal mx plus c. So we are looking for m, and of course, once given m, we can take any pair of point, which is x1 and y1, and plug it into the equation to find the equation of the line. Let's look at some example. All right, now here question number 1 is to determine the equation of the line that is passing through the points 2 4 and -1 -2 in its general form. Let's go back to look at its general form. The general equation of a line is y equal mx plus c. Let's have a look at that. So the first thing we need to do is to calculate m. So we're going to need to say, hey, m is equal to y2 minus y1 divided by x2 minus x1. So this is more practice for us when it comes to gradient. y2, let's label our points, x1, y1, x2, 2. So m is equal to y2, which is negative 2. Take away y1, which is 4, over x2, which is negative 1, minus x1, which is 2. If you work this out, you're going to find that here is negative 6 divided by negative 3, which works out nicely to be equal to 2. And that there is the gradient of this particular line. Now that we have the gradient, as mentioned before, the general equation is y equal mx plus c, and we've just calculated m, and now we're looking for c, and as mentioned, you can use any pair of points to substitute for y and x. So if we choose to use this pair, that would be entirely up to us. And if we choose to use this pair, that's entirely up to us. So I normally stick with a routine where I just simply use my x1 and y1 values as my pair. So in this case here, y1 is 4, and m was just calculated to be 2, multiplied by the x coordinate value that matches with 4 is 2. And then we're obviously having an equation here with a variable c to solve. So 4 is equal to 2 times 4 is 4 plus c. So therefore 4 take away 4 by transposition is equal to c. So it simply means that the line is passing through the origin, which is 0. So this particular line here is going exactly through the origin. Okay? So now that we have the c value here, which is 0, then the equation of this particular line here, in conclusion, is that y is equal to 2x plus 0. We don't need to write that 0, but okay, y equal mx plus c. Alright, so hopefully that is clear on your side. Let's have a look at another example. A straight line passes through the points -5, -1, and 3, -4. We're required to write the equation of the line, but this time we're going to write it in its standard form. So let's go back here and look at the standard form of the equation is ax plus by plus c equals 0. We need it in that form. That's the form that they're asking it for in. Okay, so here we go. Again, we need to calculate m. So that's m is equal to y2 minus y1 over x2, take away x1. So here we go, we're going to label our points, that is x1, y1, and we're looking at x2, y2. So labeling our points here, we find that m works out nicely to be y2 is -4, take away y1 is -1, over x2 is 3, take away x1 is -5. So we're looking at here is that m evaluates to -4 plus 1 over 3 plus 5 by removing those clash signs. M works out nicely here to be -4 plus 1 is -3, and 3 plus 5 is 8. So the gradient of our line here is -3/8. Okay, that's the gradient of our line. Now naturally we're just going to go right ahead and process the equation of the line. So that's y equal mx plus c. And so here we're looking at using the x1 y1 pair of points to substitute for our x and y, and we've just calculated m to be -3/8. So by plugging this in, y1 is -1, m was calculated to be -3/8, multiplied by x here is going to be -5 plus c. Please bear in mind that we're looking for the equation of the line in its standard form. So here now we're just going to be simplify this a little bit. So that's minus 1 is equal to, there's nothing to cancel out here, so we're looking at minus 3 times minus 5 is 15 over 8 plus C. So if here we go and we say, all right, transpose the minus 1, transpose the 15 over 8, we're going to find here that minus 1 minus 15 over 8 will be equal to C. And if you go ahead and find the LCM of this particular situation here, zoom up a little bit, here the LCM, let's just create some space here, guys. So the LCM is going to be equal to 8. So we see 1 into 8 goes 8 times. Alright, and then we say 8 into 8 goes 1 time. So we'd have 1 time, negative 1 times 8 is negative 8. Take away 1 times 15 is 15. So this works out with a C, with a y-intercept value of minus 23 over 8. Alright, so a little crowded, guys, that's why I had to zoom up for you here. But that is basically how we calculated the C value. So now that we have M and C, we can interject and make our conclusion. So therefore we'll find that the equation of the line here works out to be y equal M is minus 3/8 x, and then C works out to be minus 23 over 8. Now this would be the correct answer if it is that we wanted the equation of the line in the form y equal mx plus c. But we're actually looking for the equation of the line to be in the form ax plus by plus c equals 0. So we've got to get rid of those denominators. So here I'm just going to multiply throughout by 8 because 8 is my denominator. So if I multiply here by 8, I'm going to get 8y. If I multiply here by 8, then the 8 will cancel here and here. So the 8 will cancel, end up with being equal to minus 3x. And then if I multiply by 8 here, obviously the 8 is going to cancel. So therefore I'll end up with minus 23. Now getting it back into that form, I'll just transpose my terms over to my left. So I'm going to transpose according to what they asked me for. I want the x value first, so that's 3x. I want the y value next, that's positive 8y. I've transposed the minus 23, so I'll get positive 23. And therefore that is equal to 0. So that now becomes the equation of the line in the form ax plus by plus c equals 0. Alright, a new little introduction here. Not sure if you guys have ever seen a situation like this before, but it's quite common when it comes to CSEC questions. So you've got to make certain that you are indeed up to par, up to speed with questions like these. Alright, so it goes a little bit deeper than you just finding M and finding C, especially when they ask for the standard form. Let's look at another couple of examples. So the line AB has coordinate values minus 2, 5 and 7, negative 1. We have to write the equation of AB in the form y equal mx plus c. So occasionally, as you can see here, they may ask you for the equation of a line without giving the line a name. Here, we've given the line a name, AB. So once again, we all start off with the normal, finding the gradient the gradient, which is m is equal to y2 minus y1 over x2 minus x1. So m, naturally, before we plug in, let's label our points. So that's x1, y1, and that's x2, y2. So y2 here works out to be negative 1. Take away y1 here works out to be 5. Over x2 here works out to be 7. Take away x1 here is negative 2. So that's 7 take away negative 2. So that's negative 6 divided by 9. So that's negative times negative is positive. 7 plus 2 is 9. Negative 1 minus 5. Add and keep the common sign. So if we can reduce this, that would be good. So we can see 3 into this is 2. And 3 into this is 3. So we end up with an answer here for the gradient to be minus 2/3. Alright, smaller values makes it easier for the calculation. We'll proceed now to finding the equation, which we know that we are going to need to calculate the value of C. So by using a pair, so what I'm going to do here is that I'm going to use the x2, y2 pair, alright, to show you that it doesn't change because the points are going to be on the line. So in the first two examples, I did use x1 and y1, but just as a demonstration, if you feel like you want to try to use the x2, y2 values, it will not change your result. So here I'm going to use y2 to be negative 1. M obviously works out to be minus 2/3. Multiplied by x here works out to be 7. And we're looking for C. Alright. So here we end up with minus 1 being equal to, there's nothing here to cancel, so that's minus 14 divided by 3 plus C. Now we had earlier used the LCM method where we kind of transpose the term here and find the LCM, but we have another method in which we could actually calculate C. We could get rid of the denominator here by multiplying throughout by 3. So we can say multiply here by 3, multiply here also by 3, and multiply here by 3. Balance the equation. So we have negative 1 times 3 is negative 3. Cancel, cancel here. So end up with minus 14 plus 3 times C is 3C. Alright. Transpose the minus 14, we'll end up with minus 3 plus 14 equal 3C. And we'll end up here with 11 being equal to 3C. Dividing both sides by 3, we're going to find that 11 over 3 is equal to C. So we have calculated our C value here. So that's another way of doing it. You can also try the LCM method to see if you still get 11 over 3. And if that works out, then you can choose whichever method you see fit. So therefore we can say that our equation here is y equal M was worked out to be minus 2/3 x, and C is 11 over 3 plus 11 over 3. They did ask us for it in the form y equal mx plus c. So therefore this concludes our final answer here. Alright, nice. So hopefully you guys are catching on to that. Now the first 3 examples that we went through were examples that were related to the whole fact that we had to find the gradient. But occasionally you're going to find where you're asked to find the equation and you're only given a pair of points. And we are also asked to calculate the gradient. Or sorry, we are provided with the gradient. Alright, so the title here is finding the equation of a line, given a point and the gradient. So this requires a little bit less working out because we are told what the gradient is. Alright, and we are actually told what our x and y coordinate values are. So sometimes this question will spook students in terms of we get stuck sometimes, and I'm speaking from a student perspective, sometimes we get stuck in terms of interpreting the question, right? We are so accustomed to say find M and then find C, but here this only basically requires us to find C. Alright, so let's jump on paper here. We end up with M being told to us to be minus 3/5. So that's good for us. So we're just going to proceed now to go into y equal mx plus c. And we are told what x and y is here, so it's easier working out. So this is x1, y1. So y is minus 3. M works out to be negative 3/5 times x is 4 plus c. Let's working out for us, guys. So that's minus 3 is equal to, nothing here to cancel, so this is minus 12 over 5 plus c. Now they didn't really specify as to what format they want it in, so I guess we can leave it in the form y equal mx plus c. You have an option here. You can use the LCM method by transposing the negative 12/5 here. Find the LCM. I don't have a lot of space. I'm just going to use that method. I'm just going to transpose over here. So that's minus 3 plus 12 over 5. And we're going to find the LCM here to find c. So c here is equal to, and the LCM here is, as you can see here, is 5. 1 times 5 is 5. So let's see, 1 into 5 goes 5 times. And 5 into 5 goes 1 time. So negative 3 times 5 is negative 15. And 1 times 12 is 12. So this works out nicely here to be minus 3/5. Oh, this is nice. So the intercept and the gradient works out to be the same. Quite interesting. Very coincidental though. That was not planned. Definitely was not planned. Alright, but anyways, here's the equation. Therefore, that's y is equal to negative 3/5 x minus 3/5. Again, they didn't ask for a standard or general form, so I'm assuming that we can just leave it in that form here. Alright, y equal mx plus c. Very coincidental question. Intercept and the gradient is the same. Alright, now here's a very interesting one now. We are now looking at similar questions where we are finding the ordinate value in an equation. Alright, so here, determine the y-ordinate of the point P on the line PQ and the equation of the line in its standard form with coordinates, say here, we're looking for the y-ordinate, correct? So the standard form with coordinate values 3y and q minus 4 minus 3 and a gradient of 2/3. Right, so it's a little tough question to some extent, but you definitely want to get in the practice when it comes to these type of questions. So of course we will need to find the y-ordinate value first, and so naturally, because we are told what the gradient is, we can use the gradient formula to our advantage. We had done a previous question like this earlier in the video, right? I'm gonna leave maybe something on screen here to show you at what point in the video, like a timestamp, to where we had just done an example using the gradient formula here to actually find. As a matter of fact, it was not in this video, it was actually in the previous video. We had done examples of finding ordinate values using the gradient formula. So here, m is equal to y2 minus y1 over x2 minus x1. Alright, now we are told what the gradient is, so remember that we are not actually calculating the gradient. We are already told that m is 2/3. So here we're just going to put 2 over 3 here for m, and that's going to be equal to, now we have all the coordinates. So that's going to be x1, y1, and that's going to be x2 and y2 here. Okay, let's take our time and plug those in. y2 is minus 3, and that's going to be y1 is y, so y1 is missing, and so x2 is negative 4, and that's going to take away x1, which is 3. So a lot of the times, guys, you may not necessarily understand the question, which is good. You're supposed to try to understand the question, but sometimes you just gotta just lay some stuff out on paper, plug some values in, and then you'll find things revealing itself to you. So here, what's revealing itself is a fractional equation that I have to solve to get the y-ordinate value. So therefore, now we're looking at saying here 2/3 is then equal to, obviously we cannot take y away from -3. We can reduce here to -7. Alright, now we can cross multiply here and get some stuff done. Okay, so if we can cross multiply here, we're going to find that we can start with this side. 3 multiplies -3, we end up with -9. And also the 3 clearly has to multiply the y here. So 3 times -3 is -9. 3 times minus y is -3y. And that's going to be equal to, cross multiply over here now. 2 times -7 is -14. So we have a very simple linear equation here to solve. So we have -9 minus 3y equals -14. If we transpose the -9, we'll end up with -3y being equal to -14 plus 9. This will work out to be -3y is equal to -5. And so y is equal to -5/3. -5 divided by -3, which y is equal to 5/3. So the y-ordinate value, right, is a fraction. So 5/3 would have to be right here in order for the gradient to be equal to 2/3 according to this layout. Okay, so a very interesting approach to the question, right? And this is something that we have already done in part 1, so definitely check that out. If you're watching the video for the first time, you want to get accustomed to how to use the gradient formula to actually determine the x or y ordinate value. Now we're not finished because they did say that we should calculate the y ordinate value of p. So right here it's 5/3, and they said the equation of the line. So again, we know that we already have m, which is 2/3, and so x. Alright, so we didn't necessarily need to do this to find the equation of the line. We had to do this to find the y-ordinate of the point P, but we had this supporting pair here. Now, even though I always tell you that you should use x1 and y1, we didn't actually have the x1 and y1 pair here. So we could use the x2 and y2 pair here. Now, if it was a case where you were given the question with only one pair of point with the y-ordinate point missing, then you'd have to go through all of this to get the equation. But we had a support here, so we could actually go ahead and say here that since the gradient is 2/3 and y is actually -3 and x is -4, then we could say that -3 is equal to the gradient, which we said is 2/3, multiplied by x, which you can see here is -4, plus c. Alright, I hope you guys get it, because sometimes based on the structure of the question, you may be provided with only one point, and not only are you provided with one point, one of the ordinate value of the point is missing. So sometimes we can make the question get a little complicated. Not that I've seen a structure like this in CSEC, but it does exist, so you have to be very, very aware. Alright, and be very quick to handle situations like that. So -3 is equal to 2 times -4, that's -8/3 plus c. So here we go then. We could use the fraction method. Obviously I don't have a lot of space, so I'm just going to work with this here. Bring over the -8/3, so we end up with -3 plus 8/3 equals c. You can find the LCM here. So the LCM here works out to be 3. 1 into 3 times 3. 3 into 3 times 1. 3 times -3 is -9. plus 1 times 8 is 8. So C here works out to be minus 1/3. That is C. Alright. So therefore then, we can conclude our final answer to be that the equation of the line is y equal m, which we said is 2/3 x, and the y-intercept here is minus 1/3. Did they say in its standard form? Yes, they did. So we need to go an extra bit further here by multiplying throughout by 3. Now I don't have a lot of space, guys, so I'm just going to allow you guys to do it. Alright, and let me know if you got the answer to be negative 2x plus 3y plus 1 equals 0. Just let me know when you use the standard form if that's what you get in the comment section below. Alright, make sure that you guys do it. Okay, so this is what you're supposed to get when you are done putting it in its standard form. So I think that this is a very condensed and a very interesting question, a nice complete question for a coordinate geometry problem, right? It brings out a lot, your algebra skills, your application skills, the interpretation of the question skills. This is a really nice 6 marks question here that will bring out a lot in terms of you being a student. Okay, all right, so we have just gone over an hour of coordinate geometry. Let's bring this tutorial to an end. In part 3, we're going to be looking at another variation when it comes to finding the equation of the line. We're going to look at, for me personally, a more simplified formula that allows us to do less work. Now in the examples that we are doing here, notice that to find the equation, we have to always find C. Not only do we have to find M, but in addition to that, we have to find C. Now in this particular introduction in part 3, depending on how much work I have left to do, I may have to actually go ahead and do a part 4, right? But for now, I think that part 3 will suffice. We're going to be looking at a more simplified version for finding the equation of a line using the formula y minus y1 is equal to m multiplied by x minus x1. Alright, let's bring this tutorial to an end. Thank you so much, guys, for watching. Please share, subscribe, like, and leave comments down below. Video request. Thank you so much for watching. See you next time in another tutorial session. Bye bye.